Hello everyone, I Arpita Tripathy welcome you all to my channel and your very own learning platform, The World of Chemistry. Today I'll continue my discussion from the last topic, atomic structure. So keep watching my videos and to know about my latest updates, do the needful. From this module, you'll collect some ideas about Rutherford's atomic model and his theory about atoms, Bohr's atomic model, discovery of neutrons, properties of neutrons, and comparison of the subatomic particles. So let's initiate our discussion. J Thompson proposed his plum pudding model or blueberry muffin model in 1904, where he compared the electrons with raisins or blueberries and protons with pudding or muffins. His atomic model explained the negatively charged electrons are surrounded by the positively charged protons. His model can also be explained by taking an example of watermelon, where the seeds resemble the electrons and the red edible part resembles the protons. According to him, each atom was a sphere of positive protons with negative electrons embedded in it. But as his model failed to explain many experimental observations about the atom, so it was not accepted. Later, in 1911, Ernest Rutherford carried out his gold foil experiment to find the arrangement of electrons and protons in an atom. As a result of his experiment, the plum pudding model was replaced by his atomic model. Based on his experimental findings, Rutherford published his views on atomic theory. According to him, maximum mass of an atom was concentrated in the center of the atom called nucleus. The nucleus is the densest part of an atom and contains positively charged particles, the protons. The size of the nucleus is extremely small as compared to the size of the atom as a whole, as there is a lot of empty space around the nucleus. An atom is electrically neutral, that is, the number of protons and electrons are equal. Electrons revolve at some distance, much like the planets revolving around the sun. But Rutherford's model also failed to explain about the stability of an atom. Rutherford's model of atom does not say anything about the arrangement of electron in an atom. An electron revolving around the nucleus gets accelerated towards the nucleus. An accelerating charged particle must emit radiation and lose energy. Thus, the electrons in an atom must continuously emit radiation and lose energy. And because of this lost energy, the electron would slow down and will not be able to withstand the attraction of the nucleus. As a result, the electron should follow a spiral path and ultimately fall into the nucleus. If it happens, then the atom should collapse in about 10 to the power minus 8 seconds. But this actually doesn't happen. Atoms are stable. This indicates that there is something wrong in Rutherford's nuclear model. However, this was not the end of the story. In 1913, Niels Bohr, a Danish physicist, proposed a modified version of Rutherford's atomic model. According to Bohr's model, all the electrons revolve in discrete orbitals and the electrons filled up in these orbits as per the rule of 2n square, where n is the number of orbital. He named these orbitals as the first shell is K shell, second as L shell, third as M shell, and fourth as N shell, and so on. The number of electrons are fixed according to the 2n square rule. First K shell will have 2 electrons. Next, L shell will have 8 electrons as n is equal to 2. So according to 2n square, 2 into 2 square will be 8. Likewise, the third M shell will have 18 electrons, and so on. These are discrete orbitals where electrons revolve but does not radiate its energy. Bohr's model also explained that these shells have a fixed size and energy. The shell nearest to the nucleus, that is the K shell, has the minimum energy, and as we go farther, the energy increases. Now let's know about the discovery of neutrons. By the time Rutherford gave his atomic model, it was found that the atom was entirely concentrated within the nucleus in the form of protons, as electrons had negligible mass. However, during subsequent experiments, it was found that the mass of an atom is far more than the total mass of protons present in the atom. It was realized that another atomic particle should be present in the nucleus that had mass but no electric charge. In 1932, a British physicist, James Chadwick, announced that the nucleus also contained a new uncharged particle which he called the neutron. Now let's understand Chadwick's experiment. He placed a source of polonium in an evacuated chamber. In front of the polonium source, a thin foil of beryllium was placed. The alpha rays were made to hit the foil of beryllium. The beryllium foil emitted the mysterious neutral rays. Chadwick placed a target in the path of these rays. These rays knocked out atoms from the target, and as a result, these atoms, which became charged as a result of collision, were made to enter a chamber filled with gas. These charged particles ionized the gas, and the ions drifted towards an electrode, constituting a current. By measuring the current, he estimated the speed of the ejected atoms and came to the conclusion that the mysterious rays contained particles having mass almost equal to that of the protons. Chadwick identified these uncharged particles as neutrons. So let's see the properties of neutrons. Neutron is an integral part of an atom and is present inside the nucleus. It is of the same size as that of a proton. It is electrically neutral, that is, has no charge. Here is the three fundamental subatomic particles of an atom with their properties. So let's compare it. Proton, it is present inside the nucleus having charge 1.602 into 10 to the power minus 19 coulomb. Its mass is 1.67 into 10 to the power minus 24 gram, which is almost equal to 1 atomic mass unit. Neutron, it is located inside the nucleus and its charge is 0 as it is neutral. Its mass is 1.68 into 10 power minus 24 gram, which is almost equal to the mass of the proton, and is 1 atomic mass unit. Electron, it is present outside the nucleus. Its charge is minus 1.602 into 10 to the power minus 19 coulomb. Its mass is 9.11 into 10 to the power minus 28 gram, which is almost negligible, that is 0. So hope this content of the module will be helpful for all. Thanks for watching and have a good day ahead.